Well, good afternoon, everybody. Can you hear me? Is this mic working? Okay. So who so far at the conference has gone to other talks about functional programming or lambdas or RxJava or reactive extensions? Some of this might be repetitive to you. So it might be good to get an additional view on it. I don't plan on going deep on either of those topics, just kind of giving an overview and how and why you might want to use it, especially in the context of Android. And the goal here is to speak to Android developers, but really it's relevant to anybody working in Java. And hopefully get you excited about this alternative way to do async programming. So that leads me into kind of the overall scope or context of this talk is it's about async programming, right? Especially with Android or any other kind of UI type of system, a client that has a UI. You can't do a lot of work, or you don't want to do any work other than maybe rendering the UI and handling events from the UI on the UI thread. So you're going to have to offload your work to a background thread. And doing that inherently has some challenges, and we'll talk about some of those. But in general, if you're working on Android, you have some classes that help you do things on a background thread. One of those obviously is the thread itself, the class thread. You can dip all the way down there and start threads yourself if you want to. You probably don't want to. You probably want to use things that help you manage threads and coordinate them. Something like an executor can help you coordinate threads. Yes? Speak louder or turn up the mic. I'm not sure how to turn up the mic. Let's see. Yeah, I don't know how to work this thing.
Maybe just move it up on your color.
Is that better?
Yeah.
It was off, so that helps. All right, step one, turn on the things you're supposed to be using. Okay, so in Java we have things, we can use the thread class by itself. We can use something like an executor to help coordinate our threads. Android gives us some extra things to help us do background thread operations. Kind of at its lower level is something, you can use something called a handler thread, which uses a looper and handler all together to basically create an event loop. And you create a new thread that can process events serially on the background in a looping style. And this is actually what Android uses to process its events on the UI thread. You can create your own copy of that mechanism and do things on the background as well. But typically, we're going to go higher level, higher abstraction, and kind of use some of the tools that Android has given us to let us easily go to the background and come back to the UI and stuff like that. So we don't have to worry about getting our data to and from threads. Async task will help with that. Async task loader is kind of a specialization of that same mechanism that helps you do caching when you rotate the device, so you don't have to hit the network again just because you turn the device to a landscape. Another way to do work on the background thread is an intent service. This is if you want to do a long-running background work that's not tied to a specific screen. You're going to use a service, and intent service makes this easy to work with. But in this talk, we're going to kind of focus around async task and async task loader, maybe why they're not the best tools, and some alternatives using RxJava. And along the way, anybody has any questions, just throw up your hands. This can easily turn into just a discussion. We don't have a huge group here, so it's easy to just stop and talk about stuff. And thanks for sticking around till the last session of the day, by the way. I'm sure a lot of you are ready to get out of here. So anyways, async task. Like I said, basically from your fragment activity, you can fire up an async task. It'll handle creating a background thread, doing some work, coming back and managing getting that data, that result back to the UI thread for you. Sounds very simple, right? Why not? Why wouldn't you just use this? Well, one of the main flaws in the design of async task is that it doesn't support handling exceptions. That's kind of crazy, right? So what developers usually end up doing is creating their own kind of, they subclass async task and maybe handle the errors and then dispatch to their own custom methods to try to like figure out what's going on. Why do that extra work? Why, deal with different implementations on every project, and every developer has their own style and way of doing it? Not very consistent. Another problem with async task is if you want to compose these things together, maybe you have one task that goes off and gets the result from network, and you want to do something with that result, so you want to go off and do something maybe with a database. And every time you start dealing with async tasks, there's a lot of extra code and boilerplate involved, and it gets kind of messy pretty quick. Another problem with async tasks is if you kick off multiple of them consecutively, you want to go off and do a lot of background work in parallel. Well, it doesn't support that by default. You're going to have to give async task a custom executor. So you're thinking about threading and all this stuff, and the whole point was for you not to really think about threading. So, for example, your last async task wouldn't actually start until all the previous ones started, unless you go through that and give it a custom executor. Talked about loaders. They help you with, they're very similar to async task, but they help you with rotation. So if you were to initialize your loader, it will go off and do the background work and update your UI. If you rotate the device, the next time you initialize the loader, it's going to say, oh, I've already got this data, and just immediately call back to the UI. So that's one nice thing about using a loader. The problem is loaders don't give us any way to handle exceptions by default. We have to come up with our own methods. So enough about async task and async task loader. Let's talk about RxJava. So RxJava is a library that lets you do functional reactive programming in Java. We'll talk about what that is, what that means, but first we'll talk about where RxJava came from. So Rx stands for Reactive Extensions. It was created by Eric Meyer at Microsoft. I don't even know, 6 or 7 years ago at this point, maybe more. Netflix ported this to Java a few years back. It just hit 1.0 a few months back. And Rx reactive extensions are everywhere in every language. So the nice thing about it is if you learn how to use reactive extensions in Java, that same exact paradigm, some naming changes to fit the platform you're on, but in general, everything conceptually exists in all these other languages, and you can kind of go to and from the different languages and program in the same style and achieve the same goals. It's quite nice. So reactive extensions at the highest level, the concepts, the why it exists and the how it was implemented is really, it's a combination of the observer pattern, iterator pattern, and functional programming. Kind of these three concepts melded into one. So what's reactive programming? Let's first, to answer that question, let's look at what's not reactive. So everybody's seen some code like this before, right? It's super simple. We'll set x equal to 2, y is equal to 3. We'll add them together into the variable sum. And now sum is equal to 5, right? Now what if we go and we update x to equal 4? What does sum equal now? Well, it's still 5, right? We haven't, sum is still the value that it got before. It didn't react to any of the changes that we made. So an alternative view to this is think about a spreadsheet. If you have a value x and y cell, and then you have a sum of those two cells, and you start out by putting the value of 2 in x, and that sum cell is 2, right? Then you add 3 to the y cell, now your sum is 5, and you can then change x to 4, and it reacts to the new value, and then the sum cell will equal the new value of 7. So this is kind of a reactive style of well, under the covers, reactive style of programming to achieve this type of end result. Let's look at iterable. So iterables by default are not reactive, right? So you have a collection of things and you want to iterate over them and get each of the values out of this collection. Now the consumer of this collection is going to call next to get the first value, and so on until it's out of values. And the thing is, the consumer, while it's going through this collection, can't go off and do anything else. If this collection behind the scenes is, making a web request for each item, or if it's going through a database or some sort of expensive operation, you can end up blocking, if this is your UI thread, you wouldn't want to do something like this. So your consumer can't go off and do anything else until it's consumed everything in the collection. So the alternative to this, the reactive alternative to this, is using something called an observable, which gives you the same way of thinking about collections as iterable, except it's more of a subscription-based and push-based way of approaching it. So your consumer can say, hey, I'm interested in things that you have, and then it can go off and do other work. And at some point in the future, whatever's producing these values can say, hey, I've got something for you. Here's the next value. So, okay, I'll handle it. Now I handled it, I can go off and do more stuff. And then now, and so on and so on. So the producer can push things when they're ready and tell us when it's complete, when it's ready. And the whole time the consumer's free to go do other things while that's happening. So that's kind of two ways to look at the reactive style. You're reacting to things kind of being pushed to you versus you having to sit and wait, right? Now the other side of the functional reactive combination is the functional part. I'm sure a lot of you have seen a lot of functional things. We're in the functional room today, obviously. That's probably why this talk got put there, even though it was originally a mobile talk. Let's look at what's not functional, right? So we have some code, we have a collection of integers, and we want to iterate through them and create another collection of those integers but doubled. So the very imperative way is we're going to create a new one, we're going to define where we're going to start the index, where we want to end, how we're going to increment through them and pull them out. There's a lot of stuff going on here. There's a lot of how to accomplish the goal here. And then now let's say we wanted to take those values and filter them out so we only get the values that are less than 10. Again, we're creating a new collection, we're saying, okay, we want to step through this, and there's a lot of just kind of mechanics here that don't really communicate what you're trying to accomplish. It's just kind of the nuts and bolts of how to accomplish it. So kind of a functional alternative would be to, like I said, here's the highlighted values. This is really what's happening that you care about. These are the important parts. It's highlighted. There's a lot of grayed out code that just you don't really care about. You just have to do because otherwise it wouldn't work. So a functional style will kind of reduce all that stuff down into what really matters. So you have your collection of integers and you just want to double them, right? So you're going to map those values to this function that takes the value and multiplies it by 2. And out comes a new collection of doubled values. It's a very declarative style. You're just declaring what you want to happen and not how. Again, if you want to filter, you can say, I'm just going to filter and only select the values that are less than 10. And so on and so on. You can reduce to a single value with things like sum. You can sort by applying a function, essentially a function here called from the integer class compare, and so on, right? You can compose these functions easily as well and make something that's very easy to read. Just say I want to take my integers, map it to this function, filter, and so on, all in line, and make very concise code. And you end up with more expressive code, and it's a lot less error prone. You don't have all these mechanics that can go wrong along the way. You're just applying a function and letting it go. Now, another benefit of this is not only the concise code, you're freed to not worry about how this code is actually running. So by default, maybe it's going to run one at a time serially, and you're going to process. So here's an example that has a collection of widgets. We're going to filter out maybe bad widgets. We're going to convert them to sprockets via a map, and then we're going to make a list out of them. So this can all happen back to back on one thread, but let's say this changing a widget to a sprocket is a very expensive operation. There's nothing that stops this, because each of these channels, none of them depend on each other. So there's nothing that stops us from splitting off to 4 different threads, you know, coming down and filtering and mapping to sprockets, and then joining them back up here at the end into a single list. You know, if you were going to take your for loop iterator and make it multi-threaded, you're going to have to change the whole way you implemented it. Now, if you're using functional style, you don't have to really think about that. You can kind of just change, just tell it to run it a little bit differently. We'll talk about that in a minute. And, you know, in general, we're not going to be doing simple things like I times 2. Our applications will probably have more meaningful things in our domain. Maybe we're going to take a Kelvin value and convert it to Fahrenheit, or we're going to create some JSON and turn it into customer objects so we can work with them. So you know, in general, a function is basically something with inputs and outputs, and there's no side effects along the way. You keep them pure like that, then you can easily parallelize them on different threads, and you don't have any issues with threading problems. Okay, now if anybody here is an Android developer, you'll be like, well, that looks great. You know, these lambdas are nice and concise, but I can't use them. We'll talk about, that's where I'll talk a little bit about Retrolambda. But if you're an Android developer, you've probably seen code like this 1,000 times, or written code like this 1,000 times, right? You have a click listener, you have to create a new on-click listener, the anonymous inner class, and then, you know, so on and so on. But really, all you care about is the fact that it's going to give you an instance of the button, and you're going to do something. May or may not be with the button, but you can boil this down to a lambda. That's what a lambda essentially is. It's a anonymous inner class that has just one method. Taking this a step farther, you can also use something called a method reference. If your lambda has the same input parameter as the method you're calling, you can just kind of skip that whole step and give it a reference to the method, and it'll forward it along, like so on. So you can actually just say map customer new, and this double colon is the syntax for the method reference. Now, the new is a little bit different. Usually it'll be an actual method, but the colon new, double colon new is kind of a convention just to get you to the constructor. So if you haven't seen that. So I mentioned Retrolambda. So Retrolambda is something you can easily apply to your Android project using a Gradle plugin. It will basically you'll set your language level to Java 8 in your IDE. You'll write lambdas in Java 8. It'll compile your code to Java 8 bytecode. And then the Gradle plugin for Retrolambda kicks in during the build process. You don't have to think about all this. It's done for you. But it will kick in and convert the Java 8 bytecode to Java 7 bytecode. And then that can then be dexed into something that the Android could run. So that's how that works. It's been great, and there's been no really downside to it until recently. Java came out with a new compiler called the Jack and Jill. There's 2 different parts of this new compiler. And the reason Jack and Jill exists is to skip the Java to class bytecode to dex and go straight from Java code to dex, right? Because it's skipping the bytecode, the Java bytecode step, Retrolambda currently won't work because that's kind of how you get there. Just know that if you're thinking about using it, you currently kind of need to decide, do I want faster build times because of the Jack and Jill compiler, or would I rather not want to shoot myself because I get to use lambdas? Personally, my choice is still to use lambdas because otherwise the code is just a nightmare. It gets really bloated, especially if you're doing things like using functional programming, things with RxJava. You have anonymous inner classes that just start piling up. All right, so let's bring this all together, functional plus reactive, and kind of a code sample and workflow, and see how they all fit together into a somewhat realistic use case. So let's say we have, in general, we want to hit a web service. We want to convert some of this JSON into real objects and then convert it to a list along the way, we would end up writing some code like this. And we'll step through each piece step by step just to see what it's doing and how that flow works. So let's say we've created a web service class and a get customers method, and it will hit a web service and return some JSON. And say it looks like this. We end up with a JSON object that represents the response as a whole. But we actually want to get access inside of here to this, collection of customers. So to do that, anytime, if you're familiar with flat map basically goes from an item to an observable. An observable is, as we looked at before, something that will emit more items. So it's kind of a one-to-many relationship if you think about it. And the reason that flat is in that word is it will take, an item into many, so you could get this tree of things, and it will flatten it down into one single stream again, as if you're consuming one stream. So that's why flat map is called so. So we're going to take this one response. We're going to use flat map to get into the customer list inside of this response, and it's going to output customers individually. So it looks something like this conceptually. So JSON emitted, flat map, and now we get individual customers coming out that we can then transform and process. So the next thing we do is we're going to want to map these JSON customer objects into actual customer POJO objects. Now let's assume this customer constructor knows what to do with the JSON and set its fields up and everything like that. So you can just say map, and map is one-to-one. So anytime we get a JSON customer, it will map to a new POJO Java customer, and so on. And now we've transformed those into something that's a little more easy to work with. Now let's assume we want to filter out any of these customers that aren't local. So anything that matches the isLocal test, we'll keep on making it through this pipeline. So for example, we have customers 1, 2, and 3. 2 is not local, so it doesn't make it through, and we end up getting out of the other side of this filter customer 1, 3, and then it's done. And at the end of it all, we're going to reduce it down to a list. So, and the to list is automatically going to collect all these items and put it into a list. You can do things like to sorted list if you want to, and give it a comparator. I can never say that right. And have it sort by name or things like that. If you want to put it into a list view and display it to your users. So what that looks like is this. You go from many items down to one. You get a list out of the other side. And then it's done. So, and let me go back to the first one. I should have had it. So with 5 lines of code, we've coordinated all of this activity in a very concise and easy to read way. And if we wanted to make a modification, we want to maybe add a new filter or some other transformation in the middle, it's easy to just kind of plug in a new building block to this thing. We don't have to go in and kind of figure out what our loop's doing, and if I make a change here, is it going to break there? It's a very compositional way of building up these complex things. Let's go back forward. And we can also kind of subdivide this in a way too. Let's say there's some parts of our app, some consumers want the whole list unfiltered and they want to know about all the customers. Maybe your master list of customers, right? So you can kind of declare this into an observable, it's all customers. And then maybe you have another part that only wants the local customers as a list. So you can actually, off of this, add the filter in the to list. And what we've done is we've kind of recomposed the functionality in different ways. Some of it's reusing the previous pipeline and then adding on to it, depending on the types of things we want to do with it. So if you think about it, and I like the blocks, I like looking at this in blocks because it's kind of like Legos. You can kind of plug these things in different ways to make transformations, and you don't really worry about affecting the other transformations and other parts, the blocks you've built up. Now, everything we've talked about right here so far, everything at the top, if you run this code, nothing's actually happened yet, right? You've just declared what you want to happen. And that's what makes it a declarative style. Until you actually call subscribe on this observable, none of this code actually runs. So let's assume maybe you're in your fragment and you say, okay, I actually want to subscribe to this observable and get this list of customers. So .subscribe kicks that process off. It goes off and does all the work and channels it through till you finally get a list out. And the parameter, the first parameter here is the onNext from that observable. So, which is just going to be one list because we've kind of boiled it down to one list. So when you get the list, we can just call the method display. And then if we happen to get an error, we can handle the error. If you notice here, we actually have a native way, a standard way to handle errors. As I talked about before with async task, you'd have to come up with your own homegrown method to do that. So it's very nice. And any error that happens at any level down here will get surfaced almost like a call stack, right? But not, I mean, it's a different mechanism that it flows through your pipeline, but it will make it up to your kind of top level subscriber that actually cares about the error and can do something with it. Now, if there's other errors along the way you want to handle specifically, you can do that as well. That's a slightly more advanced topic, but just know that that's possible as well. If you want to, if you get a 401 from your web service and you want to retry, you can kind of catch that, retry, move on, and then refresh your token or something like that. And then another way, as we talked about before, you can use kind of the shorthand version and just give it the method reference. Does that make sense so far? Any questions along the way for it? Yeah.
So about that warning about the Jack and Jill compiler, would that mean like if you're using that library that you mentioned, would it like not work on devices that are running Art? Your application?
It works fine on devices running Art. It's just the compilation process. It requires, so the Jack and Jill is just going to skip. It's going to go straight from your Java file to Dex. There's going to be no Java 8 to Java 7. There's no opportunity to turn your Java 8 bytecode into Java 7 bytecode because that step is completely gone. So, but as far as running it on devices, it runs just like any other application. It's just how you compiled it. Yeah, it just depends on the compilation process. Now, I imagine they won't remove the ability to compile the current way. They're going to introduce a new way to make it better for us and faster to compile. But I think the risk is pretty low of you all of a sudden one day not being able to compile your project. And even then, if that happened, you're just stuck with a tedious task of going through and changing all of your lambdas back to anonymous inner classes. Just get the interns on it and you're good, right? Well then, bad luck. Good question though. All right, so at this point I haven't really talked about anything Android specific when it comes to RxJava and its implementation. This is all very general Java stuff. So let's talk about, other than Retrolambda obviously, but let's talk about more specific Android things. There's so RxJava is a library. It's an open source library you can go download and include it in your project as a dependency. RxAndroid is an Android specific library that pulls in RxJava plus some extra stuff that makes working on Android a little nicer. Some of those things are specifically Android schedulers. So I didn't talk much about schedulers. We'll talk about them more in a minute. But schedulers are how you declare where you want the work to run basically what thread you want it to run on. So the Android scheduler gives you the ability to say, I want it to run in the Android main thread. And you would do this for the subscriptions so you can update the UI. There's a class called App Observable. It'll give you some protection against the subscription running maybe after the activity or fragment's been destroyed. And there's Lifecycle Observable, which lets you hook into the life cycle of fragments and activities. And you can do things like, we'll talk about it in a minute, but automatically unsubscribe and non-destroy or something like that. So you don't have to worry about managing the unsubscribing part. Okay, so threading. We haven't talked much about threading, and by default, things are going to be all run on the same thread, but it's easy to kind of configure what thread they run on. We don't have to go change any of the code we wrote to make it run on different threads or in thread pools. So I mentioned schedulers. If you use this method subscribe on, now this is kind of confusing because it seems backwards, but just stick with me. So subscribe on will say everything above this in the chain, run it on this thread or this scheduler, and schedulers.io is it's going to provide a thread pool for running IO type operations, networking and disk. There's other ones. There's a computational thread. There's other types of things you can use. So if you say subscribe on schedulers.io, it's going to run everything above it in that background thread pool. Now if you say observe on, it's going to run everything below it in this scheduler. So we want all the hard work that happened above it to be in a background thread pool. We want to run our UI handling on the Android main thread. And you really, that's it. You just declare that, and it takes care of it all for you. It'll figure out how to optimize, maybe depending on the cores of your device and resources available, how many threads it should use, and all that stuff. You don't have to think about that. But there's also some other ways to clean this up and get that information out of here. I mentioned Android Observable is a class that helps you. It also will automatically do the observe on Android main thread for you, so you can get rid of this if you are binding to the app observable. And you probably want to do this because, like I said earlier, it gives you the protection against the handling happening after the fragment's been destroyed. So you end up with just telling what the subscribe on is going to be, but really you're going to want to probably move that information into the thing that's intensive. So earlier I mentioned there's this web service get customers call. Imagine its code, its implementation is making a web service call, parsing the input stream into some JSON string, and then it's calling on next. It's as an observable itself. It's probably best if you tack that subscribe on IO thread pool inside of here, so you don't have to really think about it again. Everywhere that is making use of this web service, it's automatically going to happen on a background thread pool, and it's out of your mind, and you've taken care of it once, and it's done. So you end up with kind of back to where we were, where all you're saying is, hey, I just want to subscribe to this thing. And you can also kind of use a static import to get rid of this and clean up the code so maybe the usage actually looks like this inside of your fragment. You're just saying, I want to bind this fragment to this observable and subscribe to it. And then pass along the results to some methods that do something interesting with it. Put it on the screen, handle the error, and so on. So and this one slide is showing quite a lot of power with not very much code. It's easy to kind of gloss over that. If you were to go write the code to manage all this imperatively, you'd end up with, I'd have to do 6 or 7 slides, right? Any questions along those lines? Yes.
If you resume your active or your fragment, is there anything that will like run your callback once it comes back to active?
Yeah, I'm actually, I think that's it's one of my next slides. So I'll talk about that here in a second. So I mentioned earlier, if you use the app observable to bind to the fragment, let's say you subscribe to an observable and then you hit back. And then on next is called, it's gonna, oh, nothing's there, it's just gonna automatically unsubscribe from it. Saves you a lot of headaches. And then the lifecycle observable, there's different ways to achieve whatever you're trying to achieve, but one of the default ways is, let's say you subscribe to an observable inside of OnResume, it will look at, if you're not familiar with the Android life cycles, there's kind of startup events, create, start, resume, and then there's the equivalent teardown events, pause, stop, destroy. It will automatically unsubscribe on its matching destruction event. So if this gets paused, the unsubscribe will fire automatically and you don't have to worry about it. And next time you come back into that fragment or activity, resume will resubscribe to this. And depending on the behavior of the observable, it will kick off again and give you what you want, or you can even handle caching, which we'll talk about in a second. So this is kind of the basics, just how you might achieve some very common things in Android with RxJava. But I want to go through some really cool other use cases that, I don't know, blew me away when I found out the kind of power this thing has. One example is this. This is similar, but it's also different enough that it's worth walking through. Let's say we're going to call one web service, we're going to get a list of US capitals. Then we're going to want to turn around and get the weather for all those US capitals, but only the ones that have a population of greater than 500,000. Now, if we were to use async task for this or some other mechanism, one request relies on a result from the other, and then another one, we're going to do potentially a lot of requests, and if they happen serially, it could take a very long time. You might want to do them in parallel. There's a lot of considerations here to optimize this code. But this takes care of everything I just described. So say we write a web service that gets the US capitals. We talked a lot about what that might look like. We're going to flat map it to get out that list of cities. We talked about that earlier. And then this is another, we're going to filter out anything that's below 500,000. Now we're going to flat map it to another web service. And it's going to return an observable of the result from that web service. Now let's imagine, there's probably not a ton of US capitals that meet that criteria that make it worth it, but let's say it's worldwide and we're going to make 100 requests, or 1,000, who knows. Hitting this web service to get the weather for every one of those cities serially could take a while. But behind the scenes, since this is declaring it's going to run this stuff on the IO thread pool, this is going to just kind of split off into parallel threads, get the weather for all these cities in the most optimal possible way, and then come back with the result that we can then sort all these cities by name. If we were to write code to do this, it would get fairly complex. We'd have to create an executor thread pool and try to synchronize all the different, joining all the threads coming back and make sure that we're waiting on everything right. And what if something goes wrong on one of those threads? I don't know. This is just a great way to achieve some complex things and also have the code be easy to read and easy to modify. Another thing that's kind of cool is like you can do something called debouncing. Let's say you've got a UI where maybe it's like a dial or a stepper and you're adjusting the temperature on your thermostat. and you're hitting up, 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 like you're really cold. You hit up like 8 times. And your UI in general is designed to automatically make the changes as they occur. You don't have a save button anywhere or anything like that. It's just automatically saving your values. Well, if you hit up 8 times, you don't want to make 8 web service requests that actually maybe connect to your hardware in your house. That's a lot of expensive stuff that's wasted. So you can do something by using this debounce operator. It's like, and all it really says is, let's wait until stuff stops happening for 2 seconds, then we'll send off this web request. So at this point, you've taken these 8 updates that, you know, if they all happen within 2 seconds of each other, we haven't sent off all those mid ones. It's just the very last one that occurs. 2 seconds pass. Okay, we'll send the update now. You know, if you were to go build code yourself to handle this, it wouldn't be quite this concise and simple or easy to change. Another thing you could do, another use case for this is maybe a search box. Your user's typing in and you want it to automatically populate, you know, some suggestions or some search results. Say, well, let's debounce it half a second, and then we're going to kick off the search if they've paused long enough, you know, other than every single type or character they type in, kicking off that web service request. So that's one really cool thing you get out of the box, one of the tools you get with RxJava. Earlier he mentioned something about maybe, I don't know if you were getting at caching, but let's say you have, we talked about earlier the loader example where you rotate the device, you don't want to go kick off all these expensive requests again just because your user changed orientation. One way to handle, there's many ways to handle this, but probably the simplest way is to just, if you're working inside of a fragment, set the fragment to retained, and then store a reference to this cache. So this cache is interesting. It's an observable that will replay whatever it played the first time when you resubscribe to it. So if you store a reference to this cache of this observable, and when the view is created, it will subscribe to it and kick everything off because that cache has not been initialized yet. But if you rotate the device, onCreate won't be called again, so this doesn't change, but the view gets recreated. And it's going to subscribe to this, which is the cache, but it's already got the cache filled, and it will just spit right back out those values. You don't have to go hit the network again. Cache is a nice operator for that. You can also move this cache type of behavior off into, you know, some singleton type objects if you don't want it to be tied specifically to the life cycle of your fragment or activity, and you want to manage it in a, you know, your services layer or something like that. You can do things with caches, or there's something called subjects, which act a lot like event buses. If you're interested, if you've used event buses in the past, you can use a RxJava subject as an event bus, boom, just out of the box. So let's see. Yeah, to wrap it, any other questions before I sum everything up, I guess? So, yeah.
Will you show us how to, you said it was before, to take advantage of this, you use a Gradle plugin, the 80K?
Yeah.
And that's basically, I mean, it's pretty trivial to do that.
Yeah, if you've worked with Gradle, it's really easy to pull in dependencies and plugins. So you basically, in your build, I can maybe pull up an example, but in your build script dependencies, you include the one-liner to get the Retrolambda dependency in, and then you say apply Retrolambda inside of your app modules Gradle file, and you're done at that point.
Okay, just hook into the build process.
Yeah. You'll need to also change, I think, the language level of your project to 8, so you can take advantage of it. It doesn't do that automatically, but that's really it. In the matter of, if you know what you're doing, in a matter of 30 seconds, you can have it Retrolambda enabled. Yeah, it's pretty great. Mm-hmm.
Also on Retrolambda, it doesn't give you any of the Java 8 stream IO stuff.
Yeah, it's just Lambda syntax. The streams not included.
Any other technology
Well, a lot of this, a lot of the streams functionality is very similar to the RxJava functionality, right? The main difference is you get that extra kind of iterator, the collections interface, and the reactive style. So it's a lot like Java 8 streams, but it's more of the reactive style by default. It's async by default and things like that. Yeah.
Gotcha.
Yeah. So just to conclude, yeah, I've done the last 2 or 3 projects, full-blown production apps for clients that are out in the App Store, building the architecture primarily on RxJava and using its mechanisms to achieve whatever goals we're trying to achieve. And it's worked nicely along with Retrolambda. So I recommend it. It gives you a much more robust interface than the standard classes Android gives you, which is a shame. I wish they kind of gave you better tools out of the box. And you can do a lot more complex things than you ever probably imagine getting into it, like threading and pooling and functional programming in general. Once you get that bug, it's hard to go back, just the expressiveness that you get. So in light of Android being stuck on Java 7 and not getting streams and all these things, it's my personal opinion that RxJava is really the only way to achieve this kind of power. And like I said earlier, lambdas make your code much cleaner if you're doing this type of functional programming. Otherwise, you end up with a lot of extra boilerplate code. So, yeah. All right. Yes?
Do you have any resources you can point us to?
Well, maybe I can pull it up. The reactive extensions documentation online is pretty amazing. So, like I said before, there's lots of support for all of these different languages. But if you go specifically, this is kind of small, huh? If you go to the RxJava wiki on their GitHub page, there's lots of documentation that talks about all the things I've talked about, but in much greater depth, right? So different things you can do with observables, all the different operators you can use. It's hard to even like pick and choose ones to talk about because there's so many. It's a large tool chest of things that you can use, and you kind of have to get in there and understand what tools you have and how and when to use them to really achieve the full power of it. But you still get a lot of the benefits right out of the gate without having to understand every single operator that you have at your fingertips. But luckily their documentation is really good, and I should probably talk a little bit about the marble diagrams. Here's filter. We talked about filter. Looks like they changed the marble diagrams recently.
This is all Android independent here.
This is completely independent of Android. It's just RxJava documentation. Yeah, they changed. But they have these diagrams that help you visualize, because a lot of the stuff conceptually might be hard to visualize what exactly is happening. And these marble diagrams will kind of give you a different view to help wrap your brain around it. I'm trying to find a good example of that. I guess filter, for example, we have that. Did something similar here where the top level observable is emitting these items. You have this filter, and then these are the ones that made it through into this new observable stream. There's lots of different examples of each operator and how they affect streams like this. So you'll want to reference this documentation quite a bit. Yes.
So I feel like I've read probably 3 or 4 articles on React and trying to understand it. And most of them start with that rack RAC thing, which I noticed you didn't go into. Do you have a specific spot where you say this is too much, like just stick to a certain part of React?
As far as trying to understand the whole set of tools,
Team, like if you're giving guidelines, like how deep do you go, right? Are we going to have this like 15 things in a row that's got rack, tying 3 variables together, and, just all that complexity? You find that it gets out of control with the team of people?
It can get out of control, and I think creating smaller units that are composable and easier to understand on their own, and trying to compose them again. It's like any other code where you want small chunks that on their own are independent and easy to understand, and then you can kind of compose them together. I treat this the same way. It's just you have to think about it differently and how you dissect and compose these things. Is that at all what you're talking about?
Yeah, I just didn't know if you guys had guidelines where it's like, the code is just, if you're not familiar with it, pretty hard to look at when you jump in.
Yeah, there's a steep learning curve for sure. Yeah, it takes a lot of working together and sharing knowledge. I wouldn't want to set a new person off on their own in a corner for days or weeks, writing this code if they've never done it before. So a lot of pair programming and code reviewing and mentoring and teaching, and it's a collective, and everybody's going to be learning something new and sharing the ideas. It's a very collective type of experience. Yeah. And start small. Try not to go too deep too fast and get yourself in a mess you don't understand. Try to stick with the tools you understand, and then dabble in new ones slowly. Yes.
So let's say the new version of Java supports Java 8, then will Retrolambda will not be needed anymore?
Yes. That would be wonderful.
Yeah. Do you see any changes that the developer would have to make to when Java 8 comes in?
Yeah, let's say tomorrow they announce official support for Java 8. The code that you've written and you have in your source control should just work. You should just unplug Retrolambda, say stop doing your thing, and it should work when you're compiling with Java 8. But I doubt that's going to happen anytime soon. Yeah. Okay. If there's no more questions. Yes.
I'll ask a question. Would you mind sharing your thoughts on the relationship between reactive Rx and domain-driven design? How do you see the two play together?
So kind of a traditional, well, maybe not traditional, but more object-oriented model, and playing with that functional pipeline and how they work together. Yeah. So let me see if I can go back here. In general, so I think it's still valuable to have a rich domain model, right? Have things that are good at some objects that can, do things relative to the domain, and you have them, represent the problems you're trying to solve, and then you can kind of plug them in to this pipeline. I don't know if I have a good. Yeah, this doesn't really show exactly a good example of that, but maybe the mapping, how you get from one object to another, might have some domain knowledge built into it. So you would have an object that would manage that knowledge inside there and provide that mechanism. some behaviors like, I don't know, let's see, you have special ways of calculating some sort of, tax or whatever. A lot of those things would start becoming, functions possibly, and not objects as they were traditionally. But then at the same time, you have your services layer that knows how to perform all these rich domain things on your behalf, and it's using observables as kind of the language to talk to your consumers of that knowledge. So it's a weird, it's a good question, because it's a weird way to change the way you think about what is your domain model now. Is it, it's not just a bunch of objects anymore, or maybe those objects are actually just functions, and you can pass them around in a more fine-grained capacity and compose them together. So I don't know if that answered your question in any way, but it's a question I think about constantly in this new world, trying to figure out like what it means to be, both have a rich object model and create things in a functional way that can be optimized and terse and everything. Yeah. Okay. All right, well, thanks for sticking around till the last. Yeah.